session. Now we were in the middle of binomial trial. Basically, trial means an experiment. Now, what type of experiments will be called as binomial experiments? Whenever you conduct an experiment, if the probabilities do not change from experiment to experiment, such experiments are called binomial experiments. So it doesn't mean that probabilities are equal for all sample points. That is happening in case of coin and die. So here probabilities are 50% for both the sample points. Here probabilities are 1/6 for all sample points. It is not necessary. What I mean to say is probabilities do not change from trial to trial. It does not mean that probabilities of all sample points are same. So unfortunately that is happening in this case. Okay. Now when you look at this experiment, so we have an experiment which takes 3 sample points, 1, 2, 3. Assume that probability of getting 1 is 10% and getting 2 is 70% and getting 3 is 2%. Now in this case, so the probabilities are different, but why it is called binomial trial? If probability of 1 is always 0.1, if probability of 2 is always 0.7 and probability of 3 is always 0.2, irrespective of the number of times this experiment is conducted, and in that case this is called a binomial trial. Okay, so the best examples of binomial trials are tossing a coin and rolling a die. Note these points. If the probabilities of sample points of an experiment, if the probabilities of sample points of an experiment, if the probabilities of sample points of an experiment do not change from trial to trial, if the probabilities of sample points of an experiment do not change from trial to trial, then the trial is called a binomial trial. Then the trial is called a binomial trial. Example 1. P of h equal to 1/2, comma P of t equal to 1/2, P of h equal to 1/2, comma P of t equal to 1/2, even if a coin is tossed any number of times. P of h equal to 1/2, P of t equal to 1/2, even if a coin is tossed any number of times. Example 2. P of 1 equal to 1/6, comma P of 2 equal to 1/6, and so on, comma P of 6 equal to 1/6, even if a die is rolled any number of times. Even if a die is rolled any number of times. Therefore, tossing a coin and rolling a die, tossing a coin and rolling a die are binomial experiments. Tossing a coin and rolling a die are binomial experiments. Now in the coming few minutes, we discuss distributions. 5 types of distributions: binomial distribution, Poisson distribution, exponential distribution, uniform distribution, followed by normal distribution. For all distributions, we require probability distribution functions followed by 3 statistical parameters: mean, variance, and standard deviation. What we discuss? All 5 types of distributions: binomial distribution, Poisson distribution, uniform distribution, exponential distribution, normal distribution. For all the distributions, we need probability distribution function PDF followed by 3 statistical parameters: mean, variance, and standard deviation. Okay, very important session. So listen to me very carefully. The first type of distribution is binomial distribution. Now in this distribution, the probability distribution function PDF is given by this. P of x equal to r equal to NCR into P power r into Q power n minus r. This is the probability distribution function in case of a binomial distribution. Now let us discuss what is this capital P, small p, what is n, what is r, what is q. Here n is nothing but the number of times a trial is conducted. The number of times a trial is conducted. Now here r is nothing but the number of times success is achieved. So r times we were getting success. That means the remaining n minus r times we were getting failure. Now what is this small p? This small p is probability of getting success one time. Probability of getting success once. And this small q is probability of getting failure once. So small q is probability of getting failure once. So can you guess the relation between small p and small q? This relation connecting small p and small q is p plus q equal to 1. Now therefore you can see we were getting success r times. That means we were getting failure n minus r times. Now what is this capital P of x equal to r? This P of x equal to r is represents probability of getting success r times. Probability of getting success r times when a trial is conducted n times. Now I have conducted an experiment. For example, I tossed a coin 4 times. What is the probability of getting one head? So I may feel that getting head is success and getting tail is failure. Or you can assume that getting tail is success and getting head is failure. No matter whatever you take, final result will be same. So here a trial is conducted n times. So how many times I am expecting success r times? Out of n times we are expecting success r times. So trial is conducted n times, I am getting success r times. That means the remaining n minus r times we are getting probability. So this is small p is probability of getting success once and small q is probability of getting failure once. But I should get failure n minus r times. So q into q n minus r times, so it becomes q power n minus r. How many times I am expecting success r times? So this is a p into p r times p power r. Therefore this is capital P, this is small p. So what is the difference between small p and capital P? This capital P represents the probability of getting success r times. Basically this x is a random variable. Here x is a random variable. So therefore I am storing success inside the random variable. Probability that we need to get success r times out of n times. Therefore this is the PDF in case of binomial distribution. Now in this case the mean values are like this. The mean of binomial distribution is NP. This P is this P, small p. And variance equal to NPQ. And standard deviation is square root of NPQ. Square root of NPQ. Now can you tell me the range of the values of R? So here the R values are ranging from 0 to n. R values are ranging from 0 to n, because if a trial is conducted n times, I may get success 0 time or 1 time or 2 times or 3 times or maximum n times. Got this? So mean value NP, variance NP, standard deviation square root of NPQ. So for all distribution, PDF is very, very important and followed by mean, variance and standard deviation. So first write down these points. Heading binomial distribution. Binomial distribution. The PDF in binomial distribution. The PDF in binomial distribution is given by. The PDF in binomial distribution is given by capital P of x equal to r equal to NCR into small p power r into small q whole power n minus r. Capital P of x equal to r equal to NCR into p power r into q power n minus r, where n is the number of times a trial is conducted, r is the number of times success is achieved, small p is probability of getting success, q is the probability of getting failure once, and P of x equal to r is the probability of getting success r times. So write all these points: small n, small r, small p, small q, connection among p and q, range of r values, and this capital P of x equal to r. Once if it is over, write these three lines: mean value, variance, and standard deviation. Poisson distribution. Poisson distribution. Now in this distribution, the PDF is given by this: P of x equal to k is e power minus lambda into lambda power k by k factorial. Here k values are ranging from 0 onwards. So you can see here x is a random variable. So the probability that random variable takes 0 value or 1 value or 2 or 3 etc. So k takes infinitely many values. Infinite random variable takes infinitely many values. But now let us see what is this lambda. Here lambda is average value. So therefore here mean or average equal to lambda. Even the variance value is also equal to lambda. So the standard deviation is square root of lambda. Now this is the only distribution where mean and variance are same. Mean value, average value both are same. Here lambda is mean value, variance is lambda. Mean and variance are same. If the name of distribution is not mentioned in the question, sometimes they may give clue about Poisson distribution. They may give question like this: in a distribution where mean and variance are same, that means 100% it refers to Poisson distribution. So mean value lambda, variance value lambda, standard deviation is square root of lambda. Now let us see when Poisson distribution is used. Suppose questions may be like this. Suppose in a particular city, average there will be 3 accidents in a week. What is the probability that there will be at most 4 accidents in a week? At most 4 accidents in a week. That means you need to find probability that x is less than or equal to 4. When you write less than or equal, it refers to at most. When you write greater than or equal, it refers to at least. If they ask you what is the probability that there will be exactly 2, it refers to x equal to 2. Okay. So therefore, whenever the problems are related to number of accidents or number of failures, something like that, or average number of students pass in the examination like that, in that case the distribution refers to Poisson distribution. So this is the PDF. Okay, mean value, variance value, and standard deviation. Note these points. Here the PDF is given by P of x equal to k equal to e power minus lambda into lambda power k by k factorial, where k equal to 0, 1, 2, 3 etc. K equal to 0, 1, 2, 3 etc. So mean or average equal to lambda, variance equal to lambda, SD equal to square root of lambda. So this is standard deviation. Next one is uniform distribution. Now let us see what will be the PDF in case of uniform distribution. In uniform distribution, the random variable takes values over closed interval a comma b. So when specific time is given, then it refers to uniform distribution. So when the domain of a random variable is closed interval a comma b, then it refers to uniform distribution. That means random variable x takes values over closed interval a comma b, but it takes infinitely many values. Between interval a to b, we have infinitely many values. Therefore, this is a continuous random distribution. Continuous random distribution. Now let us see in case of binomial distribution. The random variable x is taking values r, but r values are ranging from 0 to and so on n. How many values are there? In case of binomial distribution, we have discussed p of x equal to r. R ranges from 0 to n. Totally we have n plus 1 values. That means we have finite number of values. Therefore, binomial distribution is a discrete random distribution. But in case of Poisson distribution, the random variable x value, but x is nothing but k. They takes infinitely many values 0, 1, 2, 3, etc. So it is continuous random distribution. Similarly, when you look at uniform distribution, that the random variable takes values over closed interval a comma b. Now in this case, the PDF is given by like this: f of x equal to 1 by b minus a if a less than or equal to x less than or equal to b, 0 elsewhere. 0 elsewhere. So whenever x belongs to this interval, the PDF is non-zero number 1 by b minus a. Whenever we write closed interval a comma b, generally b is greater than a. So therefore, f of x is 1 by b minus a if x belongs to this interval. Outside this interval, the value is 0. Now the average value is b plus a divided by 2, mean value. Variance is b minus a whole square by 12. The standard deviation is square root of this, so we get b minus a divided by square root of 12. It is very easy to evaluate all these values. Mean value will be evaluated like this: expectation of x. Here the PDF is defined over closed interval a comma b, so a to b x into f of x dx. Now what is this? Integral a to b x into f of x is 1 by b minus a dx. Therefore, this is 1 by b minus a into integral x is x square by 2. Limits are from a to b. So therefore, this is 1 by 2 into b minus a into this is b square minus a square. Like this, you will get mean value as b plus a by 2. Variance also you can easily find. So variance is given by sigma x square. This is e of x square minus e of x square. So what is e of x square value? This is integral a to b x square into f of x, that is 1 by b minus a dx. Now this is 1 by b minus a into integral x square is x cube by 3. Limits are from a to b. Now therefore this is 1 by 3 into b minus a into this is b cube minus a cube. So therefore this is b square plus ab plus a square divided by 3. Now you can subtract square of mean value. From that you will get variance like this. So like this. So getting mean, variance, standard deviations are simple issues. You need not go for derivations. Just you try to remember this formula: mean value, variance, standard deviation. So this is the way to get mean value, variance and standard deviation. But it is not required for you how to get mean value and variance and standard deviation. Just by using normal definitions, you apply them, you get the values. So therefore, this is my PDF. This is mean, variance and standard deviation. Note these points. In uniform distribution, comma, the PDF is in uniform distribution, the comma, the PDF is given by f of x equal to 1 by b minus a if a less than or equal to x less than or equal to b. If a less than or equal to x less than or equal to b. 0 elsewhere. 0 elsewhere. mean or average equal to b plus a by 2, variance equal to b minus a whole square by 12, SD equal to b minus a divided by square root of 12. SD equal to b minus a divided by square root of 12. So when specific interval of interval is given, then the distribution goes under uniform distribution. You need not write these values. Next distribution is exponential distribution. Now let us see the PDF in case of exponential distribution. Here the PDF is defined like this. F of x equal to lambda times e power minus lambda x if x is greater than or equal to 0, 0 elsewhere. 0 elsewhere. So whenever x is greater than or equal to 0, that is, here the PDF is defined on entire positive x-axis. So 0, infinity, and this is minus infinity. It is defined over positive x-axis. So whenever x is greater than or equal to 0, the PDF is given by this lambda times e power minus lambda x. Outside these limits it is 0. Here lambda is a constant which is greater than 0. Lambda times e power minus lambda x when x is non-negative, or elsewhere it is 0. Here the value of mean is 1 by lambda, variance equal to 1 by lambda square, standard deviation equal to 1 by lambda. Now this is the only distribution we have where mean and standard deviations are same. Variance is square of this. So ultimately SD is square root of this, you will get 1 by lambda. Mean value, standard deviations are same in case of exponential distribution. So if the name of the distribution is not specified, so they may say like this. Sometimes they may give PDF like this. When a PDF is similar to like this, it becomes exponential distribution. In case of exponential distribution, you have exponential function. Okay. Of course, even you have exponential function in case of Poisson distribution also. So, but whenever you have exponential distribution followed by some constant, 100% it refers to exponential distribution. Okay. So in this case, mean value 1 by lambda, variance 1 by lambda square, SD is 1 by lambda, where lambda is a number which is greater than 0. Note these points. In exponential distribution, comma, the PDF is given by, in exponential distribution, comma, the PDF is given by f of x equal to this, f of x equal to lambda times e power minus lambda x if x greater than or equal to 0, 0 elsewhere. F of x is lambda times e power minus lambda x if x greater than or equal to 0, 0 elsewhere, where lambda is a constant greater than 0. Where lambda is a constant greater than 0. Next, mean equal to 1 by lambda, variance equal to 1 by lambda square, SD equal to 1 by lambda. Here also easily you can get, PDF is given, you can easily get mean value, integral 0 to infinity, because the lower limit is 0, integral 0 to infinity, apply this. So it refers to gamma function, and apply gamma function properties, you will get mean and variance very easily. So apply the definition of mean value, integral minus infinity to plus infinity x times f of h dx. But here it is running on positive x-axis, so limits will be changed to 0 to infinity. So apply limits 0 to infinity, it goes under gamma function, and then apply gamma function properties. You can easily get what is mean, what is variance, what is standard deviation. Okay. So next concept is normal distribution. This is the last distribution, normal distribution. Now here the random variable x runs from minus infinity to plus infinity, entire x-axis. So this is a purely perfect continuous random distribution because it is running from minus infinity to plus infinity. See, Poisson distribution is a continuous random distribution because random variable is taking values from 0, 1, 2 onwards. Even exponential distribution, but it takes values from positive side only. Uniform distribution, it restricts to only some specific interval a to b, but this is the only continuous random distribution where it runs from minus infinity to plus infinity. Now in this case the PDF is given by like this. So the PDF is f of x equal to 1 by square root of 2 pi into sigma into e power minus 1 by 2 into x minus mu by sigma whole square. This is the PDF in case of a normal distribution. So what are the limits of x minus infinity to plus infinity? So this is my PDF where minus infinity less than or equal to x less than or equal to infinity. 1 by square root of 2 pi into sigma into e power minus 1 by 2 into x minus mu by sigma whole square. This is the third distribution where exponential function is involved. Actually, exponential function involves in Poisson distribution, exponential distribution in normal distribution. So if they want to give problem related to this, so they have to specify the name of the distribution. If the name of the distribution is not specified, they have to mention PDF. So based on PDFs also, you can easily classify whether it comes under normal distribution or Poisson distribution or exponential distribution. So this is my PDF. Now you can see here mean value is mu and variance is sigma square. The standard deviation is sigma. Now when you look at this distribution, all statistical parameters are involved in this. So this is standard deviation, sigma square is variance, mu is mean, So note all these points. In normal distribution, comma, the PDF is given by, in normal distribution, comma, the PDF is given by f of x equal to, in normal distribution, comma, the PDF is given by 1 by square root of 2 pi into sigma into this, where minus infinity less than or equal to x less than or equal to infinity, and mean value, variance, standard deviation, like this. Generally, this f of x is also denoted by n of mu comma sigma square. So frequently they may use this notation even in the examination. Very standard notation, n of mu comma sigma square. This f of x is also represented by this n of mu comma sigma square, a normal distribution with mean mu and variance sigma square. So this is given by this. Note this point. A normal distribution with mean mu, a normal distribution with mean mu and variance sigma square. A normal distribution with mean mu and variance sigma square is denoted by n of mu comma sigma square. A normal distribution with mean mu and variance sigma square is denoted by n of mu comma sigma square. Therefore, n of mu comma sigma square, n of mu comma sigma square equal to 1 by square root of 2 pi into sigma into this. So even you write this, n of mu comma sigma square equal to this. Next one, perfect normal distribution. Perfect normal distribution. This is a special kind of normal distribution. By giving specific values to mean and variance, you will get some normal distribution that we call it as a perfect normal distribution, right? Even I will tell you why it is called perfect normal distribution after a few minutes. Suppose when you take like this, a normal distribution with zero mean and unit variance. So zero mean and unit variance. So in that case, this is called a perfect normal distribution. A normal distribution with zero mean and unit variance is called a perfect normal distribution. Now in this case, this becomes n of 0 comma 1 equal to 1 by square root of 2 pi into, here sigma square is 1, mu is 0. Therefore, this becomes 1 by square root of 2 pi I into e power minus x square by 2 if minus infinity less than or equal to x less than or equal to infinity. So this is the PDF for standard normal distribution or perfect normal distribution. You can call them as perfect normal distribution or standard normal distribution. Normal distribution has another name. This is Gaussian distribution, because Gauss is a French mathematician who invented normal distribution. He had a lot of contributions towards distributions in case of probability and statistics. Gauss is a famous French mathematician who invented normal distribution. So on his name, it has got Gaussian distribution. So therefore, a normal distribution with zero mean and unit variance is called a standard or perfect normal distribution. So therefore, this is n of 0 comma 1. Note this point. A normal distribution with zero mean and unit variance. A normal distribution with zero mean and unit variance is called a standard normal distribution or perfect normal distribution. A normal distribution with zero mean and unit variance. A normal distribution with zero mean and unit variance is called a standard or perfect normal distribution. Therefore, n of 0 comma 1 equal to this. Note this, n of 0 comma 1 equal to this. N of 0 comma 1 is 1 by square root of 2 pi into e power minus x square by 2 if minus infinity less than or equal to x less than or equal to infinity. Now let us see the graph of standard normal distribution, that is n of 0 comma 1. This is very, very important. Graph of n of 0 comma 1. It looks like this. So here origin is located at this place. So mu, actually in case of normal distribution, mean is mu. So the graph will have a peak at the mean value, again downfall starts. Again downfall starts. It is a bell-shaped curve. So it is in the form of a bell shape. Now let us see, it has a peak at the origin value. Now this value is actually mu minus sigma, and this value is mu plus sigma. Now when you go through this, now the area between these is 34%. This is 34%. Even basically they are probabilities. Now this is mu minus 2 sigma, and this is mu plus 2 sigma, and this is mu minus 3 sigma, and this is, for example, mu plus 3 sigma. Now 34%, 34%, this is 13.5%. This area is also 13.5%, and this is 2.5%. This is again 2.5%. So here mean value is 0. So mean value is 0, variance is 1. When variance is 1, standard deviation is 1. So this is 1, this is 2, this is 3. And this is minus 1, this is minus 2, this point, and this is minus 3. Therefore, what does it mean is, when you contribute total percentages, 68 plus 27, 95, 2.5 plus 2.5, it gives 100%. That means when you integrate this function, minus 3 to 3, 1 by square root of 2 pi into e power minus x square by 2 dx equal to 1. You can see from minus 3 to plus 3, this is minus 3, this is plus 3. From minus 3 to plus 3, whole 100% area is covered. 2.5 plus 13.5, this is 16. 16 plus 34, 50. So on left side 50, on right side 50. So it is 100%. 100% means 1. So when you calculate this integral minus 1 to 0, integral minus 1 to 0, 1 by square root of 2 pi into e power minus x square by 2 dx. This is 34%. Minus 1 to 0, 34%. So basically this is 0.34. 0.34. So when it goes from minus 3 to 0, minus 3 to 0, 34%, 13.5%, 2.5%, 50% is covered. So therefore integral minus 3 to 0, 1 by square root of 2 pi into e power minus x square by 2 dx equal to 0.5%. So it is 50%. So this is 0.5. So therefore basically when you calculate those integrals, you will get these values. Actually this graph we were getting only from these calculations. So integrate this function between the limits, you will get exactly 1. When you this is standard normal distribution, n of 0 comma 1. So when you integrate n of 0 comma 1 between minus 1 to 0, the result is 0.34. So it leads to 34%. Similarly from minus 3 to 0, on the left side of origin, it contributes 50% of area. On right side, it contributes 50% of area. So from minus 3 to plus 3, this is normal, standard normal distribution covers whole area. So because of these reasons, from all the points, you will get this graph. You will get this graph. So note all these points. Very, very important this. Next definition, partition. Suppose we have a non-empty subset, non-empty set S. So we need to discuss the partition of this set S. Suppose the set is like this. This is my set S. Actually, this is a Venn diagram representation. So divide this set S into finitely many non-empty subsets. So this is one subset, this is second subset, this is third subset, this is S1, this is S2, this is S3, this is S4. So here S1 is a non-empty subset. Non-empty subset of S. S2 is a non-empty subset of S. S3 is a non-empty subset of S. and S4 is a non-empty subset of S. So we have divided the given non-empty set into 4 non-empty subsets of S, so that when you take all subsets, it contributes to S. So therefore, we have divided this set S into 4 non-empty subsets of S, so that when you find the union of all these, it covers the original set. S1 union, S2 union, S3 union, S4 equal to S. Now the intersection, there is no common point for S1 and S2. So these two are disjoint sets. Disjoint means there is no common element for S1 and S2. No common element for S1 and S3. No common element like this. That means Sy intersection Sj equal to pi for all I not equal to j. For all I not equal to j. Intersection of these two empty. Intersection of these two. Intersection of any two of these is empty. In that case, all these 4 subsets form a partition of S. I will tell you one general example. Suppose I have S equal to 1, 2, 3, 4. Suppose S1 equal to, for example, 2. S2 equal to, for example, 3. S3 equal to 1, 4. Now you can see when you add all the sets, that is add means union. S1 union, S2 union, S3 equal to S. Take intersection of these sets. Here S1 intersection S2 is pi. S1 intersection S3 is pi. S2 intersection S3 is pi. Therefore, these 3 sets, basically these are non-empty subsets of S. Therefore, all the 3 subsets form a partition of S. This is one partition. For the same set, I can go for second partition like this. Suppose S1 equal to, I can take 1, 3, 4. Suppose I can take S2 equal to 2. So therefore, these two subsets, union of these two gives whole, intersection of these two empty. So again, these two subsets form a partition. Third example, I can take whole set S1 equal to S only. That means I am not dividing that set. It's a single partition. So therefore, here I have divided this set into 3 sets. Here 2 sets, but here a single set. So how many subsets you need to divide, that's your choice. But union of all non-empty subsets of S must give original set. Intersection of all non-empty subsets must give empty. In that case, they form a partition of S. Okay. So I will continue this in the next session. Thank you so much.